So we played with numbers so far. So far, everything that we've been storing, we have turned into a float. But it came in as a string. Whenever we called the input command, it came in as a string. If I go into idle and I type this, A equals input, and I didn't create a new file. All I did is I'm typing this into the shell, which I rarely do. If I do that, it's waiting for me to type in some input. I'm going to type in hello, and now A has that string of characters in it. Now it's actually a series of characters, and every single letter inside it is separately addressable. If I typed in A, and when I say subscript, I mean the square brace, the one next to the P key without hitting the shift key. A square brace 0 in square brace, it's going to tell me H. If I do A subscript 1 in subscript, A square brace 1 in square brace E. So you can kind of get the pattern, right? You know, 2 is going to be an L, 3 is going to be another L, and 4 is going to be an O. What's 5 going to be? It's going to be an error. String index out of range. Well, why is that? Because it starts counting at 0 rather than 1. And so that's character index 0. That's character index 1. That's 2. That's 3. And that's 4. Now Python, and only Python I've ever seen is the only language that does this, has a trick to where you can get to the last character by doing -1. Rather than have to guess what the length of it is and subtract 1, because how would you get that last character otherwise? You'd have to know the length, which is 5, subtract 1 from it, 4, and then you could get to it. So I could do A subscript 4, but I could also do A subscript -1, and this is the only language I've ever seen that allows negative subscripts. See? That's the last character. What about -2? It's going to be an L. -3, another L. -4 is going to be an E. -5 is going to be H. So it allows subscripting both forward and backwards. What if we did need to know the length of that string? Well, there's a built-in function that'll do that. len parentheses A in parentheses. It says, tell me the length of the A string, which is, of course, 5.
Does C++ or any other language come with that?
Not with a negative.
I mean, what it come?
C++ doesn't have a good way of getting the length of a string, unfortunately. No, that's not true. It's arrays that it's kind of squiggly about.
Squiggly. I need to refresh my programming skills.
So you can assign a string using a single quote, like I did here, or you can use the triple quotes to make a multi-line string. Can I just restart the shell? Fine. I could do this. A equals triple quote, and then I could just start typing. Hello, there, this is long. And then close it with some more triple quotes. And then when I printed A out, print parentheses A, right? That's a multi-line string. I could have accomplished the same thing sort of by doing this. A equals double quote, hello, \n, \n meaning new line, there, \n, this, and I'm not going to do the whole thing, so I'm going to stop there. End quote. And then when I did print A, it prints hello, right? Does the same thing. But that's why we're able to get away with making our multi-line comments the way we have been in our files when I'm typing a lot of stuff and I don't want to put a hash symbol in front of each one. Then I can make a multi-line comment, because there's nothing wrong with just typing in, triple quotes and then typing in a whole bunch of stuff and then ending it in triple quotes. It doesn't consider it a syntax error. So /n is a so-called escape sequence. Did we go to ASCII-table.com and look at that in one of our prior lectures?
I think so.
I'm seeing some heads shake no. You may know it from your last lecture. Anybody else recognize this? Did we go to ASCII-table.com? Have we seen that chart yet? All right.
No.
Okay, so I'm seeing a lot of people shake their heads. No, that's totally cool. Every character you type in on the computer has to be saved as a number. And so that string of characters is actually just a string of numbers. So when I typed in HELLO in the computer's memory, there was a 72, followed by a 69, because that's the E row, followed by a 76 and another 76, because those are L's, and then a 79. What happens if you hit enter? Well, then it sends a character return line feed. That's what the keyboard sends. And so the line feed character is 10. What if you hit the tab key? The tab key's got a different value, 9. So when we're typing in text, but we wanted to get that tab in there, we can't just type in that 9, but we can put in something that gets translated into that 9. So pretty much a lot of computer languages have agreed that if you put a \n, it means the starting of an escape sequence. Why is it called an escape sequence? Because it's breaking out of its normal mode of processing. Not sure why they call it that. But anyways, it's breaking out of its normal mode. And then when it sees the second character, the one after the \, it does whatever it is. Might be a tab. Might be a new line. Might be a backspace, which is a weird idea, right? You're going to back up over something you just typed. I don't normally see that one very often, but new line is used a lot, and tabs are used a little bit. So for example, if I do this, A equals quote have \t fun end quote. The \t is the escape sequence. The / marks the beginning of the escape sequence. The second character after it indicates what its purpose is, and in this case, the T is the tab. And so when I print A out now, it's got a tab between them. If I had put a \n there, like we saw previously, it would say have on one line and fun on the other, because n means new line. I'm going to put that \b in there just to see what a backspace does. What's it going to do? When we print it out, it's probably not going to have the E there, right? Because if you typed in HAVE and then you hit the backspace key, the E would no longer be there. Well, that's interesting. When I just hit A, it dumped the contents of that out to the memory. But what if I did this, print A? Well, that's not doing much of a backspace. I'm not impressed with the backspace character. Forget the backspace character. Can't think of a good reason for it anyways. And then here's some strange ones, like the / character, the single quote mark, or the double quote mark. Well, what are those used for? What if I wanted to be able to do A equals my name is double quote Slim Shady. I'm from the 90s and I like Eminem. All right, so there we go. Well, that's not going to work, is it? That's looking like it's just all fraught with errors. And it is. The reason why is because that marks the beginning of the string and that marked the end of it, and so this data was not in the string. But you could fix that. You could do A equals my name is, and then you can use this \. Double quote means this isn't a quote that ends a string, it's a quote that I want to see inside the string. Slim Shady. And then to get that one to work, I'm going to have to do the same thing. I'm going to use a \, and then the quote, that means this is part of the string, not the end of the string. And now it's all green all the way from beginning to end. It looks like there's no syntax errors in it, and so when I print it out, there we go. I got my double quotes in it.
I am from the 90s.
Yeah, and so you can also use / single quote, or you can use \\. I think I'm going to switch over to using idle. The editor, so that I can actually type in a program. Looks to me like we may be on Lecture D. So For those of y'all who accidentally skipped this step in the prior lectures, please do not skip it this time. I want you to choose File, New File, and then Save As. File, Save As, and just put it in your favorite programming directory. All right. Is today the 30th? Yeah, what do you know? All right. Okay, so what if I wanted to put a path to a file name?
It's 1203.
I've done that 3 lectures in a row. All righty, there we go. All right, so if you know what a file path looks like, right? Don't type this, but if you see, Windows, whatever, right? You've seen that kind of thing. So if I do this, F for file name equals double quote C:\\/ TEMP / new file .txt end quote. And so in Windows and that's a pretty cool ringtone. So in Windows and in other Microsoft operating systems, each drive is a drive letter, right? And so just like if I went out to the command prompt, I could type in C:\, and then I could / there, and I could find my way to the temp directory and so on. That's what that means, but it's not actually going to work. So on the next line, when I do print, (f) in parentheses, and then when I run it, I'm not going to like the results. Yeah, not too good. What's going on here? What's going on here is that it sees that \t and treats it like a tab. And it sees that \n and treats it like you hit carriage return. So when I run it, we see a tab, and then we see a carriage return. So to fix that, I just need to tell it, oh, by the way, these really aren't escape sequences. I honest and goodness wanted you to use a real \ there. And so then you just use those double \, and it actually works as a file path.
Dial up, anyone?
Mike, close the door a little.
That's dial up for you.
Yep.
I mean, we're in here in 1996 or something like that. Our computers would just be this.
Well, that's a security problem with the dial-up too.
Oh yeah, it would be hacked all the time.
Yep.
Like, what the heck happened to our program? And our teacher would probably be Donna Wilson.
And so just like I showed / double quote, you can also use / single quote for the same purpose. You can join strings together with the plus sign, but in this case it's called concatenation when you do that. So here they show this string being hi plus there plus kin. And if there weren't any spaces here, like this, in fact there's not there, then when they printed it out, it would look like that. That's not too cool. So when you're doing that, you would definitely want the spaces there. So the plus sign doesn't do addition, but it does kind of appending, right, which they call concatenation. And weirdly, you can use the asterisk for strings, kind of like this. If I do print 3 times, quote, doggy, end quote, in parentheses,
It's not gonna work.
I get 3 doggies. Doggy, doggy, doggy. All right, so that's kind of silly, isn't it? The only time I've ever seen a good use for that is to do something like this. If I want a line of asterisks or something all the way across the screen, I could say, please print 80 asterisks. And I'm going to put the asterisk inside of double quotes. And so now when it runs, it will print an entire line. Asterisk like that. So the variable is a place in memory that holds a piece of data. You get to pick the variable names, but you have to be careful about your variable names. Not that careful, you're rarely going to run into problems, but things that will not work are if you begin a variable with a number. If you do 1980 taxes equals whatever, that's a mistake. You can't start a variable name with a digit. You can do vice versa. That's fine.
That's fine.
Another thing you can't do is put spaces in the middle of it. I can't say, tax space rate equals, like that, because it thinks it's two words. If you want to make it look like two words, that's when you can use the underscore thing. Tax underscore rate equals 56. So if we're going to put some guidelines for variable names, they can be digits or letters, digits, and underscores. I don't think this language supports using dollar signs as variable names. Some do. Let's go see. A dollar sign equals Bob. Is that legal? No. All right. So that's pretty much it. Letters, digits, and underscores. Cannot start with a digit. Those are essentially the rules. And there may be a maximum length for variable names, but I doubt we're going to hit it. In old programming languages like in the 60s and 70s, maybe variable names were limited to being 8 long. Right? You couldn't have any variable name that was greater than 8. Well, nowadays people like to create long variable names that are very descriptive. So instead of TR, you might use tax rate. That kind of thing. So a third rule, which is not a rule, you don't have to, but choose good variable names. And what are very good variable names? They're descriptive. You can tell what they are. Single letter variable names are usually a bad idea, but I use them in here because they're easy to type, and so far we aren't creating real programs that are tracking real data. So for the most part, avoid single letter variable names. Instead, you want descriptive variable names. F is a pretty lame variable name. First name would be a much better one. S would be a bad one. SSN would be a little bit better, social security number, right? But you might put social secure, right? You might use a longer word just to make clear what it is. But long variable names, while great to read, are hard to type, so I avoid them in here just so that when I'm helping y'all, I don't have to go around and find out that you left the E out of something, or swap the R and the N, whatever. They are case sensitive. So wait is different than wait all lowercase. Now that'll get people because you're used to hitting the shift key when you begin a sentence, right? And so some people would type this: wait equals 10, print parentheses, wait. That's a syntax error. This has to exactly match that. And it also has to be spelled right, right? If I did that, it's not spelled the same way, so it's not going to work. So variable names are case sensitive. Sensitive. They care very much about whether you choose uppercase or lowercase. And the last rule is that they cannot be one of the reserved words that makes up the language, like if, or while or import or def. And there's a whole bunch of reserved words, but you pretty much quickly learn the ones that we use all the time, and it's pretty unlikely you'd ever want to call a variable if, right? Like if equals quote Bob and while equals quote Jeff. You know, I'm not going to create variable names that hold these, but sometimes you can run into that situation. Fortunately, the editor tries to help us out there, right? Because if I type def, that's a keyword, and the editor is colorizing it orange to let me know I better not try to use that as a variable name. So if I try to say def is equal to 5, that's a syntax error and it's not going to run. And right now my code is not at a running state at all, because although I opened a multi-line string there, I never closed it. So I better add that here if I want to actually be able to run and test my program at this point. Still, that's going to kill it. It's not going to run. So I would need to pick something that was not an orange keyword, right? And there are plenty of others, right? While, if, and so on. One thing that this language does that most languages don't is it lets you reuse function names as variable names. I could do this, and this is a really bad idea. I'll show you why. Okay, print equals 6. And then what if I try to print hello? It's not going to work anymore because I've effectively erased what print was. Print used to be a function. Now it's just a variable holding the number 6. Now it's no good to us. We can't print anything anymore. So I don't want to do that, right? And I don't want to say things like input equals 6, because that would erase the input function and I couldn't use it for input anymore, you know, until I changed it and reran the program. So when you're choosing variable names, you don't want them to be orange, you don't want them to be purple. Black is a good variable name, color for that text. One more thing that you can do in this language that you can't do in most others, I think I misspelled sensitive wrong. Yeah, is in other languages you can't do this. I could not go around and say A is equal to Bob, with quotes around it, and then later say A is equal to 1, 2, 3. In those languages, like C++, the compiler would say, no, you've already declared A. A is of type string, and so we're not going to let you store a number in it. That's a compilation error. It would not compile. Python does not care. You can reuse a variable for anything you want. Yeah, you can, you know, declare all sorts of strange things and store them in A, reuse it over and over and over. So the code that we've been writing that looks like this, you know, x equals input and then x equals float x, that would not work in those languages because we're reusing x. We're redeclaring it to be a different data type. Here it's a string, and then all of a sudden it turns into a float. And that's legal in this language. I could do that. I could say x is equal to 1, 2, 3 with strings around it, but I can't do math with that. I can't, you know, divide that and subtract that and stuff like that. So if I wanted to do math with it, I'd have to turn it into a number. X equals float, parentheses x. But I've just redefined what that variable is. It is no longer a string. I'm only pointing that out because in other programming languages you flat out can't do that, but Python lets you do it just fine. So if you're going to make a variable that's not supposed to change, its value should remain constant, then they want you to put it in uppercase letters, like pi equals 3.14159, whatever. I should not reuse that variable for anything else. I should not later then go pi equals apple, right? Because that's going to break all my calculations later on. Some languages have a keyword that says, oh, by the way, this variable is a constant. In C++, it's this const keyword. In Java, it's the final keyword. But note, this language doesn't have a way of marking a variable as being a constant, so everyone just agrees, you know, if it's uppercase, you're making it a constant. It's something that should not change later in the code. So going back down to our variable naming rules, for cannot be keywords or function names. I'm just going to leave it keywords, which they were calling reserved keywords, so why not and reserved words, so why not I just say reserved keywords? Best of both worlds. And 5, uppercase variable names mean constants. And I'll break that rule in here too sometimes, for one very specific reason. One thing that crops up over and over is when I'm showing what a list is, a list looks like this. It's something defined inside some square braces like this. I'm going to make a list that's equal to 1, 2, 3. Right now, I have a list that consists of 3 numbers in a row. I use L because it's a list, and if I used a lowercase l, I can guarantee that at least 2 people would type a 1 there instead. With good reason, right? Sure looks like a 1. So when I'm demonstrating lists, which I'm not going to be doing for now, but when I demonstrate lists, I am going to be using an uppercase letter even though it's not a constant. Otherwise, for the most part, I'm going to follow that rule. So the book gives you the example. Tax rate might be a constant. It's not supposed to change once it's defined. Standard deduction is a constant. So variables serve 2 purposes. They help the programmer keep track of data, and they allow the programmer to refer to a complex piece of information with a single name. So back in olden days, like 50s and the 60s and stuff like that, before programming languages got this abstract, and that's not even strictly true, but if you wanted to get a piece of data from the 30th memory address, you'd just say 30 here, right? You wouldn't give it a variable name of A. You'd say address 30 equals 123, and that would write 123 out of address 30. And then if you wanted to add 1 to that, you could say address 30 equals address 30 plus 1. And then if you wanted to write that into a different address, you could say address 40 equals address 30, and it would copy that 1 from place 30 into 40. Now that'd be absolutely insane to do, and so we don't want to do that. Thankfully, we have the ability to give our data variable names. So program comment, we've been using those. This is mentioning one called a docstring. It's a multi-line string of this form. All right. I'm not going to make us follow that rule exactly. I'm not going to make us start all of our programs with a docstring. And then there are the end of line comments, which is where you use the hash, right? Put the red thing there, and the rest of the text is redlined out. It's just a comment. It explains what that code is doing, or it's a note to yourself, but it's ignored by the program. You can put syntax errors in a comment if you want, and it doesn't crash the program, right? If I did this, prempt hello, right? Like that. It's a syntax error, but it doesn't care. It's a comment. I could have written this, in Egyptian or whatever, and it wouldn't care. Yeah, let's get rid of that. That looks a little bit too silly.
Or an ancient hieroglyphics.
Yeah.
But he can't write that.
So here's an example of using uppercase letters to indicate that it's a constant, that it's not supposed to change while the program is running. Later on, you might have to edit it again because the change of rate from Canadian to US dollars does change over time. So tips related to comments and docstrings. Begin a program with a statement of purpose and other information helpful to programs. So, at the top of my program, when I'm writing some homework, if it's to calculate the area of a circle, I should describe this as being part of the, a program that calculates the area of a circle. At the very least, put which homework it's associated with, right? Homework 7. And if you feel like it, you can even copy the description of the homework and paste it into your code, and then that serves as documentation for what that code is supposed to do. Accompany a variable definition with a comment that explains the variable's purpose. Precede major segments of code with brief comments that explain their purpose, and include comments to explain the workings of complex or tricky sections of code. So if I was going to follow all that, and follow it a little bit better than what I have been doing, what if I wanted to write a program that would calculate the volume of a certain number of gas at a certain whatever? I'd have a whole bunch of variable names, and somebody looking at it might not know what these mean. So I could do this. P is equal to 1. But I might want to indicate what that means in a comment. Pressure of 1 atmosphere. N equals 2. Two moles of gas. R equals, and oh my gosh, it's been a while since I've done chemistry and I've forgotten what this number is. I'm going to make it up. I'd go back and edit it. That's absolutely wrong. This is the gas constant. It's just a constant. It's nothing that we make up. We get it from a chemistry book. Okay, it's actually bugging me that I'm... Yeah, let's just do 0.0821 is the accepted one. All right, so 0.821. That's the gas constant. And then T is equal to 400. Well, what is that? This is a temperature in Kelvin. And if you haven't taken chemistry or physics, you don't give a hoot what moles are and atmospheres and Kelvin is. But if you looked at this and you did understand those things, then you'd know immediately where we were going. If you looked at this and didn't understand those things, at least you have terms now in which to Google them up, right? Then I could do my calculation. I want to calculate V. I could declare my V variable first. You don't have to do it in this language. In some languages like C++, you have to declare your variable before you can use them. I don't really like setting something to 0 if I'm going to turn around and set it to something else in a minute, so I'm going to change the way this looks just a little bit. I'm going to say calculate volume V with the ideal gas law. See, I'm giving you lots of information about this. If you didn't know what the ideal gas law was, and I don't expect you to, then you could go and Google ideal gas law, and you would find out very quick. So V is equal to, and here I put all these things in uppercase, and really only one of them should have been uppercase. Which one should have been uppercase? R, because it's a constant. I should have made the rest of them lowercase. And just for today, I'm trying to be a really good programmer, so I'm going to put all of these in lowercase, but I'm leaving R in uppercase. So, if I go up and Google the ideal gas law, I'll see it written like this. PV equals nRT. So V equals nRT divided by P. I'm going to type this wrong. What's wrong with that? You can't just stick two things together and expect it to know that it's supposed to multiply them. Textbooks do that, but we have to put the asterisks between them. Just like if you Googled up volume of cylinder, you get some equation here, right? We can't just copy and paste that, because in programming the computer wouldn't know that an pi next to an r means that those things should be multiplied. We have to put all the asterisks in. So we're going to do that. We're going to say V is equal to n times r times t divided by p. And then we could display the results.
Okay, what's wrong with it here?
There shouldn't be anything wrong with it anymore, and if there is, then I've made a mistake. Yeah, I sure have made a lot of mistakes. Somebody tell me. You tell me, Nathan.
You have to make T and P lowercase.
Yep, I have the wrong variable names. Thank you for catching that. And I'm going to put spaces out here just to make it a little bit easier to read.
One way to break the program.
Yep, all right. So, display the results. Print volume of the gas is, end quote, comma, V, comma, quote, liters, end quote, in parentheses.
Is this the right way to do it? Just kidding.
Let's see if it works. It's very plausible I've made mistakes. Yeah, so it calculated the volume. And if I was going to write the program, what I would probably do is ask the user for what P was, and ask the user what N was, and ask the user what T was, but I didn't. All right.
Programming for STEM.
So, what was this to demonstrate? It was to use comments. Put a comment next to your variable name. Am I always going to do that when I'm writing code? No, because sometimes I'm just demonstrating a quickie little simple concept, and I don't want to put a big comment saying what X is, when X is just something that I'm storing 1, 2, 3 in, and I'm not going to put anything else into it later. But if I was writing a good program, if I was doing professional program, or say I wanted to get a really good grade and maybe extra credit, then what I would probably do is I would go in and give myself comments in the code explaining what the variables are. If it says M equals 83, I don't know what M is. But if I say M equals 83 and then I put hashtag mass in kilograms, suddenly I know a lot more about it. And I'm getting away with using single letter variable names, which I probably really shouldn't, although for math equations people do it all the time, right?
I probably shouldn't.
So if I'm typing all that information you have there,
Uh-huh.
I should have the colors.
Yeah, let me come look.
Okay.
I haven't paused and checked to see how people are doing. At this point, I have a running program. If you don't have any typos in it, syntax errors, your program should run too. And it's not mandatory to have a running program to get credit for the day, but it's always kind of nice, huh?
Skedaddle.
Question, is there, does it follow normal rules of math as far as how it does its operations?
Which rules?
Like,
And you're a math
your
professor
answer,
and I'm not, so you're going to have to tell
yeah.
me.
So, for example, like you do things inside parentheses and brackets.
Okay,
square
very
brackets.
good point. This language does follow rules of operator precedence, which in math, the correct term is probably be order of operation, meaning that parentheses happen before anything else, right? If I put parentheses here, which I didn't, but if I had put parentheses here, that would be the very first calculation that was done. So parentheses first, and then exponents, and then kind of the third tier are all the forms of multiplication, which include multiplication, division, floor division, and modulus. Now that's a whole bunch of stuff to list, so just for right now, I'm going to cut those other two off, and I'm going to say that that's multiplication and division. And then lastly, the fourth tier is addition and subtraction. Now if you look at it, here's how some people memorize these. You probably did in junior high or something as well if you had to. PEMDAS is the order of operations. PEMDAS. This is slightly deceptive because it makes it look like you do all the multiplications first and then later on you go back and do the divisions, whereas they are actually of equal priority, and so you just do them left to right as you're coming, just like addition and subtraction. just because A is traditionally listed before AS.
My dear Aunt Sally.
Yep, just because A is listed before S doesn't mean you go through the equation, find all the A's, and those are done before the subtractions. That would definitely give you the wrong answer in some cases. Instead, these are of equivalent priority. So I don't know, if we space it out like that. But anyways, yeah, just like Nathan said, the mnemonic that some people remember, please excuse my dear Aunt Sally. And why does that matter? It actually matters a lot, because if it did not follow these rules, then it would be giving different answers at some times.
I assumed it would. So it's
Right. So like if I did this, A equals 3, B equals 4. Now, let's not even do it like that. If I did A equals 3 plus B plus 10 divided by, why am I fumbling on this? Right. Somebody might think that, okay, this is 14, and then I'm going to divide 14 by 7. However, division has higher priority than addition and subtraction. So it's like there were parentheses around here. So you can see that that's a completely different answer than what 14 divided by 7 would have been, which is 2. So instead of getting 2, I would have gotten that. If I really wanted it to happen in the order in which I thought it was going to do, I'd better put that stuff in parentheses, and then outside of it, do that. The other way you can get around that is to separate it into multiple steps. Now this is kind of silly, but I could do A is equal to 3. Now I'm going to add 11 to it. A plus equals 11. And now I'm going to divide it by 7. A divided by equal 7. And then I should get my original answer. Well, I got that original answer, right? Would not work so well if I was trying to get this, right? Because this just did every element one by one, right? The 3 plus the 11 divided by 7. If I was going to do it like this, it would not work so well, but I could still separate it into several steps, right? I could say A is equal to 3, B is equal to the second half, right? 11 divided by 7. And then I could say C is equal to A divided by B, and when I printed C out, get that. Was I supposed to get that? I don't remember if I was supposed to get that. Anyways, so you can complex calculation should probably be broken up into several steps. By the time you have more than 3 or 4 or 5 variables in one line, it's a good idea to start breaking them up like that because they're easy to debug. What do I mean by that? I could print out the value of A right there after that. Say that this is a complex equation and not just a 3. And then after that calculation, I could print out the value of B. And I could double check to make sure that that's what it was supposed to equal at that time. So it could be that if this equation had been more complex right here, I might want to have broken it up. Maybe I would have wanted to do n times r times t first, print that result out just as a debug step, because you can always comment your print statements out later, and then divide that thing by p, right, and then check that result.
So going back to the previous window, you had A is equal to plus equal 11. That's just updating 11 with updating A with the addition of 11, correct?
Exactly. If I type this, A equals 10, and then I say A equals A plus 1, that's going to change A to 11. But if I do A plus equals 1,
Same thing, just short.
same thing, right? It's just a shorter way of writing it. This is called a compound operator. It's where you use the equal sign followed after the operator, and it does the calculation and then updates the original variable, which is different than if I just did this. Sorry that it's at the bottom of the screen, gang. Let me see if I can do something about that. Right, if I typed in A plus 1, it's going to print the next number, 13, but A really has not changed. If I wanted it to change the value of a, I could either do a equals a plus 1 or a plus equals 1. You'll see me do this a lot. One of the textbooks we had never did that, and so when the students saw me writing code, or when I asked about it on exam, I felt kind of bad if they didn't know what plus equals did, because there were absolutely no examples of it in the code, but hopefully they were watching my lectures as well and saw me doing it. Fortunately, this one does this. This is actually a good textbook.
It's one of the best textbooks we got so far.
The first applications of computers were to crunch numbers. Is that true? Yeah, in the 40s, you know, when the U.S. government was spending millions of dollars making these room-sized computers like this one,
With punch cards.
they weren't doing it for fun or to improve the, you know, the state of mathematics at the time. They were using it to improve weapons, right? To, you know, make atomic bombs and do all the calculations, or to, you know, create, you know, better artillery tables and mechanisms for bomb dropping and all those calculations that needed to be done. And what's kind of interesting here is you have this guy looking here and all important stuff, and then you see this woman over here, and some people would assume, okay, well, anyways, the balance, almost all the initial programmers were women at the time. All the engineers were men, because women did not enter into the engineering field at the time. But they needed people who could program these things. And so you would get like an MIT, you know, grad student or whatever, you know, a graduate or a professor of math who could just as easily be a woman as a man, and then dump a whole pile of specs on the desk and tell them to learn how to write a program, and they would. And so they actually invented the programming languages. A lady named Grace Hopper invented COBOL and another programming language and stuff like that. How did you program these beasts back then? Patch cables, right? You didn't write code in. You used patch cables just like a telephone operator in an old Spencer Tracy movie, right? And so you'd wire these modules together with patch cables, and you can see how many patch cables they have, and if there was a single mistake in it, it wouldn't work. Much worse is the fact that behind these panels were vacuum tubes to hold the zeros and the ones, right? If a tube was lit, then it held some number. If the tube was not lit, then it was a 0. Well, light bulbs burn out, don't they? So periodically, somebody had to go through and test every single one of those vacuum tubes. And if they got the wrong answer, you know, sometimes the programmers are smart enough to go, oh, well, that must have been, you know, a failure in module X7, and they could go down there and they could check the vacuum tubes. Man, do we have it easier than that. That's why we can write Fortnite and stuff like that. And so the English didn't use computers. They were doing their parallel developments at the time for weapons development. Instead, they did it for code breaking, like breaking the Nazi code, the Enigma code, stuff like that, which is just a heart of task in a way. Did not require computers of quite this size. They invented smaller ones, but the ones that they created were very, very influential, called the von Neumann architecture. And pretty much all of our computers today that we use are the von Neumann architecture. So we're getting to the point where we better have come up with some homework based on our lectures so far. So what I want to do is I'm going to write an itty-bitty little program here. Actually, what I'm going to do is I'm going to give you what's known as pseudocode. What is pseudocode? Pseudocode is a loosey-goosey description of programming. My pseudocode could look like this. Input hours. Input rate. Set total equal to hours times rate. Output total. Now that's not a programming language, because pseudocode is just an English description. Instead of input hours, I could have put the words ask user for hours, right? And it would still be valid pseudocode. Or ask user for rate. Well, we don't even know what rate it is, but this is kind of like a payroll program, right? So if I wanted to turn this into Python, instead of input hours, since this is pseudocode, it's not going to work. Pseudocode is something that you give to a programmer in order to make them write a program. And then they pick the language that they want to implement it, like Java, C++, Python, and then they do so. So we would want to do it in our language. This is the Python version of it. And you don't have to really type, type all this. I'm not going to tell you what to do. Hours equals input. But there's a problem there. Tell you what, let me unquote this because we'd actually like for it to run, right? Now I've messed it up, so what's green is not supposed to be green and vice versa. Okay, so hours is equal to input, but we better tell them what to type in. Input, parentheses, how many hours did you work? Pseudocode is a representation of an algorithm. It doesn't give you the details of how you should have programmed it. Now we're getting into specifics. We know that we want to tell the user how many hours did they work. Question mark, space, space, hyphen greater than, just to make it look real pretty. This is not an essential part of the syntax, but you'll see what it does when it runs. And then rate equals input, parentheses, what is your hourly rate? Question mark, hyphen greater than, end quote, in parentheses. Now we're going to do a calculation. What's my calculation? Total equals hours asterisk rate. And now we have a result that we can print out. So where it says output total up here, well, that's loosey-goosey. Why don't we be very specific? Print, you earned, end quote, comma, total, comma, beginning quote, dollars, end quote, in parentheses. Or we could have tried to format it better with a dollar sign in front and stuff like that. We could try to limit it to displaying only dollars and cents, but that's good enough. So we turn that pseudocode into Python.
Here's the problem.
Yeah,
You should float it.
you're right. I've made a very serious mistake, and I did this in the last class that I just did this assignment for. And what's the problem here? This returns a string. It has to be converted into a number, which is a step that our pseudocode didn't show. So after that hours equals input, I have to do hours equals float, parentheses hours. And Nathan saved me from some embarrassment there. All right, and then after the rate statement, it should say rate equals float rate. Now let's see if it works. Under here should be the green text of all the rest of my notes that I had, right? This is only the pseudocode that was underneath the volume calculation. And again, you don't have to get this working. I always upload the notes. So how many hours did I work? I worked 40. What is your hourly rate? $20 an hour. I'm sitting pretty. I earned $800. Okay. If we were really awesome and had a little bit more time, we'd go ahead and do the hour-and-a-half thing, right, where you earn over time. But we're not going to do that. What I'm going to do instead is I'm going to add a comment as to what the homework is. Homework, implement the formulas, the equations you looked up as a program. So what were the equations? Somebody remind me. You looked them up much more recently than I did.
For what?
The area and volume of a sphere and cylinder.
Yeah. So for the sphere, I better look it up. Get it exactly right.
And the assignment was due yesterday.
Well, it wasn't.
Right, so we have 4 of these. What I want you to do is I want you to turn these into programs. So to calculate the area of a sphere, you're going to have to get the input of the radius, and you can calculate the area and the volume. For a cylinder, you have to get both the radius and the volume. So the pseudocode for that, I better do the green text again because it's getting kind of long. The pseudocode for that would look something like, input radius of sphere.
I think you may want to do another.
And then, I definitely needed more triple quotes. And then calculate the area, output the area, calculate the volume, output the volume. That's what you need to do for the sphere. The next part is for the cylinder. Input radius of cylinder, but it also had the height, right? Input the height of the cylinder. Then you can calculate the, what did I want? The area and the volume. Calculate the area, calculate the volume, and I forgot to put the output statements. Output the area and output the volume. Now you looked up the formula, so I'm not going to give you the set statements, right? If you get stuck, this isn't a math class, so if you get stuck, text me and I'll scribble down the equation that you need or whatever, or I'll look at your code and I'll help you correct it.
Is this in a math class?
Yep. So homework, convert homework 1's formulas into Python scripts to perform the calculations. Remember, unlike your prof, that the input has to be converted into floats values before they can be used in math.
I saved you from
There,
massive
like that.
embarrassment.
Yep, so after you get your input, you want to do that. And here's a way that some people do that in one statement rather than two. You could do it like this. Radius equals float, parentheses, input, parentheses, quote, what is the radius of the sphere? End quote, in parentheses, in parentheses. That's how you do it in one line. You don't want to do it like that because the rest of our examples haven't been like that. That's totally fine. If you've already had programming and that clicks and makes sense, feel free to do it that way.
And you'll have all these mix-ups, right?
Yep. I'll upload all these into Canvas. All right. Let's stop and allow ourselves to upload where we are.